When doing dissections of fetal pigs or other organisms, lung tissue is it's characteristically squishy, which is owing to its porous nature. It's much like a sponge. We already know that from looking at the secondary bronchi of each lung that the left lung is smaller than the right lung, owing to that cardiac notch. And this cardiac notch is the space that the heart occupies. Lungs and their alveolar clusters are the site of a process called external or alveolar respiration. Sometimes students get to a quiz or a test and they'll come up to me and they'll be like, what the heck is external respiration? Should I know this term? Yes. External respiration or alveolar respiration. I think I think because the term respiration may have had a previous meaning for you, that the combined effect of those two words, sometimes the effect is somewhat lost. So we have to remember that terms that we once knew now are taking on a much more specific definition. So the term respiration specifically applies to the exchange of gases across a membrane. Here in the lungs, this is where we do external or alveolar respiration. This is because what is in an alveolus is not yet in your body. We have the same situation that we have with the digestive system. The contents of your GI tract are not in your body until they diffuse through the cells lining your small intestine and enter into the hepatic portal system. So, speaking of vascularization of the lungs are vascularized by two different circuits with two very different purposes. Bronchial circulation is the set of arteries and veins that serve the lungs as though they were any other tissue in the body, right? So, there is an artery bringing oxygen rich blood and a vein bringing oxygen poor blood away, and that's the same as any other organ in the body. There are also arteries carrying oxygen rich blood to simple squamous cells and the alveolar great cells in your lungs, right? So the veins of bronchial circulation carry the oxygen poor blood back to the vena cava. There's another circuit called the pulmonary circuit. This circuit is carrying blood directly from the right ventricle of the heart. Sorry, I almost said left there, through the pulmonary artery and into the lungs in order to be oxygenated. And this blood is not used by the cells of the lungs. And this blood returns to the left atrium of the heart and is oxygen rich when it does. It then leaves the aorta and is distributed throughout the systemic circuit, and it oxygenates all of your peripheral tissues. The pleura of the lungs is a serous membrane similar to that of the pericardium and other serous membranes that we've seen, right? There are two layers, right? There's the parietal layer, which is superficial. Let me just get the right color here. There's the parietal layer that is superficial, and then there's the visceral layer, which is deep. And between them is the intrapleural cavity. The visceral pleura, it also dips deep into the septa that separate the lobes. So it's just connective tissue. So we now have our first picture here really showing us very clearly the three lobes of the right lung and the two lobes of the left lung. The intrapleural cavity of each lung holds only about 1/4 cup of fluid. That's not a lot. It's not. The fluid is somewhat straw colored owing to albumin concentration, and it resembles the lipid-like texture of melted butter. So now I want you to think of a half a stick of butter being melted down. That's not a lot of fluid to lubricate each lung. Generalized terms given to inflation of the pleura is pleurisy. Pleurisy can be caused by bacteria. It can be caused by other autoimmune diseases. Pleurisy effectively inflames both the parietal and visceral pleura, and it eliminates the intrapleural cavity. So it causes the visceral and parietal pleura to rub against each other with each breath. I know this because I have had pleurisy, and it definitely feels like there's an elephant sitting on your chest. So, like any serous membrane, the pleura and the fluid-filled intrapleural space reduce friction as the lungs expand and contract in a process called ventilation. The pleura are also for containment. As with other important organs in the thoracic cavity, we do not want infection in one organ to seep into another one close by. And this is why the esophagus and the trachea have adventitia, and the heart and the lungs have these double serous membranes. The pleura play one last but very important role in creating pressure gradients in pulmonary ventilation. So we'll use that intrapleural space again. As mentioned previously, the trachea separates into the primary bronchi, left and right, which each lead to one lung, left and right. Secondary bronchi can also be called segmental bronchi. In this diagram of both lungs, the bronchopulmonary segments are diagrammed, not lobes. Those are bronchopulmonary segments. And they're listed by name for you on the corresponding secondary bronchi are labeled with the same number as the bronchopulmonary segment they serve. During development, both lungs have 3 lobes at first. As the heart becomes more established, which is, it's one of the first organs that becomes established, right? To pump blood throughout the baby's body. But as it becomes established, it carves out that cardiac notch in the left lung, and that reduces the left lung to 2 lobes. Although reduced to 2 lobes, the left lung retains the same 10 bronchopulmonary segments that the right lung has, distributing them among 2 lobes, whereas the right lung distributes those bronchopulmonary segments among 3 lobes. The common term collapsed lung usually is referring to a specific thing called a pneumothorax. In this situation, alveoli and the visceral pericardium have been breached, or the outside of the body and the parietal pericardium have been breached. Either way, the intrapleural cavity has been breached open, and air is seeping into the intrapleural space with each breath. In fact, each breath that you take pulls air into the space because there's no outlet to the intrapleural cavity. Pressure starts to build up and it pushes back against your squishy lung, right? The pressure can't expand outward, right? The pleural cavity can't expand outward. There are ribs that prevent that from happening. One of my favorite movies, this dates me, is Three Kings. It's a movie made back, I think, in 1999. And in it is Mark Wahlberg in one of his first roles as an actor, so he was still being referred to as Marky Mark back then. But in the movie, he gets shot in the lung. He has a pneumothorax, and they tap the pleural space with a valve. And that valve allows him to let the pressurized intrapleural air lose some of that air and pressure, and consequently allows the lung to reinflate. Although not a permanent fix, theoretically, it did the job in the movie. Pleural effusion has the same end result as a collapsed lung, but pleural effusion refers to the fluid buildup in the intrapleural cavity. So the same thing happens as with a pneumothorax. The increased pressure in that intrapleural cavity pushes back on the squishy and porous alveoli of the lungs. This condition can result from low pressure conditions in the atmosphere, sucking fluid out of your tissues into the open lung space. For example, at the highest elevations on Everest, the pressure of the air is so low that it's actually like wicking fluids from your body. And one of the surfaces over which the atmosphere is doing that is that incredible surface area of the alveoli in your lungs. This leads to the pooling of fluid in the intrapleural cavity and in the lung itself. Yes, you can tap that cavity to reduce the buildup of the fluid, but you have to remember that fluid's coming from your body tissues and it's fluid that you need to stay hydrated. So the other fix is that, you could just climb down the mountain and live at a more reasonable elevation for a little while.